Simplifying rationals and multiplying and dividing rationals. Simplifying rational expressions. All right, let's talk about rational expressions. What is a rational expression? It's a ratio or fraction of two polynomials. And we're not allowed to have negatives in the denominators or radicals, which we've already talked about previously in this year. But we're also not allowed to have 0 in the denominator. So that's going to come up when we talk about restrictions. So here, what are some numbers that would not be allowed in the denominator? So if I just have a linear equation, I can just set that equation equal to 0 and solve, and then that number would not be allowed. Because if I plugged it back in, -5 plus 5, I would get 0. If you have a polynomial in the denominator that is able to be factored, we have to factor first, then take each factor, set it equal to 0, and solve. So here I would get x cannot be -6 and 6. If I plug 6 squared, I get 36 minus 36, so that would give me 0, and -6 squared is also 36, giving me that 0 in the denominator. We've talked about fractions that equal 1, and we're going to use a lot of binomials here in this section that equal 1. So maybe x plus 6 over x plus 6, or x squared minus 2 over x squared minus 2. As long as what I have in the numerator and the denominator are the same, this fraction equals 1. So we're not changing the value, but we are changing what it will look like. All right, so we're going to simplify completely, and then we're going to state our restrictions. So the first thing that I'm going to always do is I'm going to factor my numerator, factor my denominator. In my numerator, I have a GCF of x squared. So we get x plus 3. In the denominator, I also have a linear equation, so that cannot be simplified. Here I notice that I have a binomial in my numerator that's the same as the binomial in the denominator. So x plus 3 over x plus 3 is equal to 1. And we're left with x squared. In order to state my restrictions, I'm going to take that denominator, I'm going to set it equal to 0 and solve. So I get x is equal to -3. So if I plug -3 into the denominator, I'm going to get 0. So the restriction is that x cannot equal -3. I'll show you another example. So again, the first thing that I'm going to do is I'm going to factor. In my numerator, I have difference of perfect squares, so x plus 1, x minus 1. In my denominator, I'm going to factor that trinomial into x plus 1, x plus 1. In both my numerator and denominator, I have x plus 1. So when I have those binomials over each other, it's equal to 1, so they cancel out. And here I have my denominator. So here's my answer, sorry. And then my denominator, the binomials are the same, so I only need to solve one of them equal to 0. So x cannot equal -1. And that's reducing rational expressions. In order to state the restrictions, we only look at the denominator. Multiplying and dividing rational expressions. How do you multiply fractions? You multiply the numerator with the numerator and the denominator with the denominator. So we'll do the numerator times the numerator, and then we'll have the denominator times the denominator. And anything that cancels, you would cancel out from there. So here, we're going to take our numerator, we're going to multiply with our numerator. We're going to take our denominator, we're going to multiply it with the denominator. We're going to start by factoring. So we have the factor x plus 3. We can't factor that at all. And then our second numerator can get factored into x minus 3, x plus 2. Right here, we have difference of perfect squares. So we're going to factor that into x plus 2, x minus 2. And then we'll factor the last trinomial, which will be x plus 3, x plus 3. Any of the factors that are same in the numerator or denominator can cancel out. So this numerator with this denominator, and then we also have this numerator factor with this denominator factor. That leaves us with x minus 3 in the numerator, and then x minus 2 times x plus 3 in the denominator. When we state restrictions, we have to state restrictions for the entire denominator, even if they canceled out. So x cannot equal -2, +2, or -3. You could also write this as x cannot equal plus or minus 2, and then -3. Either is acceptable. Okay, let's talk about how do we divide fractions. So when you divide fractions, you have your original numerator over your original denominator. You are going to change it from division to multiplication, and you're going to flip the second fraction. So now the denominator is on top and the numerator is on the bottom. Then it just converts back to how you would multiply. So here in this example, we have our first numerator over our original denominator. We're going to change to multiplication, and then the denominator of the second fraction becomes the numerator, and the numerator becomes the denominator. From here, we're going to factor. I'm going to go across, so now I'm going to GCF. So we have 3 x squared plus 1. I'm going to factor down here. Again, have a GCF. And then we have to add multiply. So now any numerator can cancel out with any denominator. That's exactly the same. So we can cancel out x minus 1. I cannot cancel out a second x minus 1. We can cancel out x squared plus 1 and x squared plus 1. So my numerator, I have 3, x minus 1. In the denominator, we have x, and then x plus 2. When I'm stating my restrictions, I have to state them for all of our denominators, so x cannot be 0. We have x squared plus 1 is equal to 0. So we're going to solve that. And we get imaginary numbers, because when we take the square root of a negative, we get imaginary. So then we get -2 and then +1. We also need to make sure, because of this was originally a denominator, that we take into consideration the restrictions that would be for that denominator. They're the same as this other piece that canceled out in this particular example. All right, and then one more. So here we have multiplication and division. So we're going to leave the first two as they are. This denominator is going to come to the numerator. And then we have our denominators that are originally in our denominators. And then this numerator is going to come down to the denominator. We're going to factor each one of those. So here we have x for this first term. For this first numerator, we had x times x squared minus 25, and that's going to factor a second time. So it's x and then x plus 5, x minus 5. You have those difference of squares. The second one, we have a GCF of 2, so we get x squared minus 1. Again, we have difference of squares, x plus 1, x minus 1. And then the last one, we have that GCF. In the denominator, we have this 4x squared. Sometimes people like to write it as 4x times x. It's fine. The middle trinomial, we get x minus 5 and then an x plus 5. I'm sorry, x minus 1. And then we have a GCF on the last one of just x. X plus 5. We're going to cancel out any factors. So we have an x and an x plus 5, x plus 5, x minus 5, x minus 1. And that looks like that's everything. So in the numerator, we have a 2 and a 7, so that becomes 14. X plus 1 squared over, and then the denominator is 4 over x squared. After I brought these together, I realized that 14 over 4 can simplify to 7 over 2. So I can reduce a little bit further. I'm going to check one more time. I don't have anything else that can reduce, so I'll do my restrictions. X can't equal 0, 5, 1, negative 5. I need to make sure that I check this one that was originally a denominator that moved my numerator. And so that also gives me negative 1.